We're going to take a look at two properties, the even and odd properties, which kind of go together, and then the periodic properties. So we're now going to be looking in terms of functions, but these properties work in general for the trig functions. So let's do a little bit of a review from algebra. We have, what does even and odd mean? So it's even and odd properties is dealing with symmetry of the graph, but also that means something about the function algebraic. So we have that even is y-axis symmetry. Now, one of the most common functions that people feel comfortable with that does have even symmetry is y is equal to x squared. That means that whatever point is on the right will be mirrored to the left, or vice versa. They're mirrors left to right of each other. So what that means is that when you plug in, right, if this is x, this is going to be negative x. So if it's 3, it's going to be negative 3. And those give you the exact same y's. So for example, one would be 2 comma 4 and negative 2 comma 4, right? So no matter if you plug in the positive version or the negative version, it gives you the same y. So the way that we write that is that f of negative x is just equal to f of x. They give you the same y. So our even functions are right here. There are two even functions, and that's cosine and its reciprocal secant. So the even and odd properties will hold for the reciprocal. So if you know cosine, sine, and tangent, the other three will follow. So that means that the cosine of negative theta is equal to the cosine of theta. Whether you plug in the positive version of the angle or the negative version of the angle, it gives you back the same exact ratio. All right? Now, odd symmetry means origin symmetry, and one of the functions that people feel comfortable with that has odd symmetry is y is equal to x cubed. So if you have a point in quadrant 1, it will mirror to a point in quadrant 3. And if you have a point in quadrant 2, it will mirror to quadrant 4. So if this is x, it will give you back some sort of y. And if this is negative x, it gives you back a negative y. So both of the sign changes. The x and the y changes. So for example, for the cube function, that would be 2 comma 8 and negative 2, negative 8. So that means that when you plug in the negative version of the x, it gives you the negative version of the y. Because remember, f of x is y. So when you plug in negative x, that means negative f of x. They both change sign. So our odd functions are the other four: sine, cosecant, tangent, and cotangent. So if you take a look here, the way it algebraically works, which is actually in this situation the way that we use it the most, we use it more algebraically than we use it graphically. So that means that when you put in a negative angle, it makes the ratio negative. So you can loosely think about it that the negative goes in the front. It's not really what's happening, but if that helps you, you can think of it like that. And with the even function, the negative, quote unquote, disappears. All right. But the reason for that is the reason above that I'm using to explain graphically. So let's take a look one more, the periodic of the trig functions. Now this is actually something that we're going to use more graphically. So intuitively, what that means is that the graph, the y values, have a pattern that repeats. And it is the smallest pattern such that happens. So algebraically, that means f of x plus p is going to equal to f of x. So you have 4 trig functions that have a period of 2 pi, and you have 2 trig functions that have a period of pi. Again, the reciprocals follow. So as long as you know sine, cosine, and tangent, cosecant, secant, and cotangent will follow. So for 2 pi, it's sine, cosine, and then of course cosecant and secant. And for pi, it's tangent and cotangent. Now, this is really going to help us when we graph, because what that means is if you can graph a distance of 2 pi for sine, then the graph will just repeat itself all the way to the right and all the way to the left. So the graph has a pattern, and we will see that in the later videos when we start to graph. Right now, what I need you to know is what the period is. That's all. Okay, so I just need you to know that sine, cosine, cosecant, and secant have a period of 2 pi, and that tangent and cotangent have a period of pi. So let's use these properties, mostly the even and odd properties. So we want to find the exact value of the tangent of negative 37 pi over 4. So what we could do to use one of our new properties would be to know that tangent is odd. So I could put the negative in the front. And then this is too big. I can already tell it's way bigger than 2 pi. So I'm going to use coterminal angles. So 2 pi with a denominator of 4 is 8 pi over 4. So 37 pi over 4 minus 8 pi over 4 is 32 pi over 4. No, it is not. It is 29 minus 8 pi over 4 is 21 pi over 4 minus 8 pi over 4 is equal to 13 pi over 4 minus 8 pi over 4 is equal to 5 pi over 4. You could also do the trick that we've discussed previously, which is to subtract, which is what I was thinking in my mind when I wrote 32. You can subtract all 4 revolutions at once. So you could do 37 minus 32 if you recognize that there are going to be 4 multiples of 8 inside 37. So this is equal to negative tangent of 5 pi over 4. And so 5 pi over 4, again, if that confuses you and you're really a little iffy, you can change it to degrees. So 5 times 45 is going to give us 225 degrees. So it is going to be right here. So it is in quadrant 3. It has a reference angle of 45 degrees. So alpha is equal to 45 degrees. I'll go here. I'll draw my little triangle. Here is 45. Here's 1, 1, square root of 2. Tangent is opposite over adjacent. And because it is in quadrant 3, tangent will be positive. That's where all students take calculus, quadrant 3. So this is equal to negative, and then the tangent of 5 pi over 4 is a positive 1. Positive because it is in quadrant 3, 1 because it has a reference angle of 45 degrees, and then the negative in the front makes the final answer negative 4. Okay, let's do one more. So we have the sine of negative 30 degrees, negative 390 degrees. So to use the properties, I'll put the negative in the front. I will subtract 360 because it's too big. That will give me the sine of 30. I will draw a little triangle. This was 60. This was 2. We cut it in half. This was 1. This was the square root of 3. Sine is opposite over hypotenuse, and when I'm looking at 30 degrees, 1 is the opposite. So I have a negative in the front, and the sine of 30 degrees is 1/2. So my final answer is a negative 1/2. And there it is.